Everyone can hear me? Okay? Okay, excellent. So, it's a great opportunity for me to meet you all and to share some ideas. I take everyone here is faculty somewhere, right? All in engineering schools or? Okay, all in engineering schools. What kind of backgrounds, like electrical and computer people? Computers, okay. Mechanical, okay. Civil, okay, civil and anybody else? Electronics and communications. Okay, and I was told that you all have a project selected. So, I plan to talk about what I've come to call CPR for engineers. CPR generally stands for chest and pulmonary resuscitation. I don't plan to teach you that, but I plan to teach you something akin to that for engineers. Okay, and the learning objective for this session, in my mind, is to help you create a framework for synthesizing the various components that you're being exposed to. So these components are being thrown at you throughout the week, and what is your organizing principle for these components? So I'm going to offer you one, and you may have your own, that's fine, but we'll start with something. And organizing in the following sense that, how do I get started? One. Second, what do I have to learn? And third, how do I know that I learned it or I have arrived? Right? That's roughly the journey. So again, to add to what Gayatri said so kindly earlier, I started out as an electrical and computer engineer. I was working at Bell Laboratories doing purely engineering type of work, but subsequently got a little disillusioned by how much technology we create and how little impact it seems to have on some of our most pressing challenges. I then also realized that as an engineer, I had tools to make things, but I really didn't have tools to actually think about what happens once I make something, right? So that drove me to MIT's engineering systems, which admits people, engineers and scientists, but it orients them to the intersection of engineering and social science. So that's what I learned subsequently. And now I do work on socio-technical systems where there is technological complexity and human complexity in problems. And specifically, my work is on information architecture for development, where I'm at a higher level interested in three questions. How do you generate information about our environments that we currently don't generate? How do you share information in innovative ways that we currently may not be sharing? And then finally, how do you make decisions based upon these new forms of information? So that's roughly the stack that interests me. I teach at Sloan School, I've been associated with the data center, and I spend something like 3 months in a year working with remote communities in India. I've never been to the far northeast. I've gone as far as West Bengal. I'll be very happy to come and learn from your work as well. So that's a bit about me. Now that that's out of the way, let me ask the following question. Each of you have projects. I believe there are 4 projects, right, in this class. Can we make a list of what would you have to get right for your idea to make an impact? What do you have to get right? Yeah, and impact may mean whatever it means to you. And I'm going to make a list of what you think these things are. Nice. That's good. Yeah. Any thoughts?
Right set of people to discuss with.
Okay. Okay. Then keep going.
Learning of the technology itself.
Okay. Others? Anybody? Anybody? Yes.
Existing technology.
Okay.
Good imagination.
Okay. Then keep firing. We should be able to generate 30, 40 of these.
Right direction to walk. Right direction.
Right direction. Okay. This is right. Okay. Then you saying something? Consistency in the work. Consistency in the work. Okay. 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 Then
Feasibility study.
okay. Okay.
Assessment. Assessment of the.
Assessment. Okay. Yeah. Exploration. Okay. Okay. Then
Going to the field.
going to the field. Right? Can I call it understanding the field? Is that okay? Yeah. Okay. Then
Understanding of the trend.
trend. Is that existing tech or some other trend?
Yeah, something like.
Same thing? Yeah. Okay. Then
The commercial part of
okay. Okay. You guys have thought?
Affordable cost.
Affordability.
Yeah.
Yeah. Okay. Okay. Then more convenience. Okay. Convenience. Okay. Ease of use. Can I call it? Is that yes? Okay. Yes.
Funding.
Funding. Funding. Yes. Very important. Okay. Then okay. Shall we move on? Okay. Technology. Yeah. Yeah. How do they connect? How do this? Okay. So that's a nice segue. So yeah. Right. So let's. That's great. So let's. So technology. How do these pieces connect? Technology and people. And whatever you've seen in the field and so on, right? So one way, I mean, there are a number of variables here. So let me, I put people in both places because one way, these, if you look at these, this bunch, that's really in some ways about um, understanding the problem, right, as to what to work on, how do you define the problem, that's the cluster, roughly the cluster here. This is roughly the cluster of that is around the solution. Okay, what will be the technology, how do I learn it, how will I imagine a solution, how will I be consistent and this will be feasible, how do I do assessment of it, and how will I do exploration. So exploration, you might say, well, exploration and imagination may be together. And so this is more about solution so far. Is that fair, reason, acceptable? Yeah. And this is more about the adoption of the solution, right? Getting it out. Right? So who will use it? What are the commercial aspects? Would it be affordable? Will it be easy to use? Is there funding for it? All of that. Right? So this is a matter of getting it out. Now some of these variables are everywhere, right? People matter both in finding problem as well as in the adoption. Ease of use matters after you have made something, but it influences how you make something, right? Right? And assessment of what? Assessment maybe of do I have the right problem? Assessment maybe of do I have the right solution? Assessment maybe of do I have the right adoption model? So assessment also appears in various places, right? So some of these things are cross-cutting, and so like this, there are a number of the basic point of this little exercise to get us in is that there are a number of different dimensions that we need to have a mental map to organize. Okay. All right. So let's get into organizing these things, and let me offer you one framework. Okay. So there's which I've come to call the CPR for engineers, where the C stands for compassion. Okay. P is for practice, and R is for research. So the fundamental question along the compassion dimension is how do I deeply understand the problem of my stakeholders? That's the fundamental question. What do I have to learn to understand the problem of my stakeholder as deeply as I can? Okay. Along the research, so once I have a problem, once I have understood a problem, the next question is how do I rigorously research this problem? That's the fundamental question there. And then once I have come up with a solution, then the question is how do I think like a seasoned practitioner to get this out? So this may be an entrepreneur, it may be a policy maker, it may be an NGO, whatever is your channel to get your idea out. But that's the fundamental question, that what do I have to learn in order to get this idea out, right? So imagine this three-dimensional space where you may, we all may start near zero, and then we are sort of trying to reach the apex. And what would I have to do to reach the apex is the journey we are trying to take. And can I organize all of my various components into this space? Okay. So now what I want to do is I want to take one axis at a time and apply it to your idea. So I'll give you an example, and basically I want to depict a journey as to where one could start, what all one could learn, and when one would know that I have actually achieved something on this axis. Okay. So let me start with this. How many people here are in an urban setting? Urban? Semi-urban, okay. Where people go to various places, right? Whatever, you are in Mumbai right now, right? So I'm showing you an urban scene right now. I want people to guess what's going on here. Shall I play it again? Okay, let's see. Let me play this again. Okay, let's, okay, so let's see. Let me just go here and say, okay. So okay, so somebody said somebody's trying to catch a train, another thought, it's a market, okay. It's a market, okay. Other thoughts?
They are blocking the train line.
They're blocking the train, okay. All right, other thoughts? Keep going. Any other thoughts? Everybody agree that these are the three possibilities? More possibilities? They want to stop the train, get on the train and get going, okay? Yeah, okay. There's some fire and there's some smoke, there may be an accident, okay? Other thoughts?
Generally, laborers collect at a place to be carried away. I've seen that near bus stand, that they collect at a place, so people carry them for the daily wages.
Yes.
It might be possible at a railway
Okay,
track.
bingo, that's the answer, all right? So this is an employment exchange. And so this is a scene from Ahmedabad. There are 14 lakh people who get employed every day like this, yeah? And these people are in such conditions all around us, and they are invisible mostly, because we're not trying to solve the problem, solve their problems. And so, like when I started learning about, so these markets are called nakas, right? We are close to something called Saki Naka here, which was not named Naka after this kind of thing, but where people get their daily jobs. And when I started studying these people, I realized that, wow, I was growing up right next to them all the while, but I was not really paying any attention to them. So my empathy, my compassion, on compassion axis, I was at 0. Right? Now, let me give you an example. So we have, in the Tata Center, they've heard about the Tata Center? Okay. So the Tata Center at MIT, the predicament is slightly higher, slightly tougher, right? So I have a Canadian like this, wanting to talk to a valve man in Mumbai Municipal Corporation, and I want to teach him something so that he forgets they both forget that their differences and they focus on the problem at hand. Right? So then I would think, okay, this person moved up the compassion axis somehow. Now, this man, very unique guy, David Taylor, who just got his PhD. When he started out his work, he had worked for the Engineers Without Borders in Africa. And he had learned that most of the cities of the world, including Mumbai and New York and you name it, they have 20 to 30% leakage through their water systems. Now, the leakage is defined differently in different places, but the bottom line is that this water is being used for something that it was not intended for, right? And he set out on this journey to say that I am going to reduce the leakage in urban water systems, so there will be more water. So he hung out with this Mumbai Municipal Corporation for about 2 months. Every day he will get up, get into his jumpsuit, go with the Mumbai Municipal Corporation and fix pipes. Then he came back after 2 months and he said that, you know what, I don't want to solve the water leakage problem. And so we were a bit nervous. And we said, okay, why? And he said, well, because I realized that if I can hypothetically fix all of the leakage in Mumbai Municipal Corporation or in other cities of India, then the poorest of poor people will have no water at all, because their only access to water is the leakage water in many cases, right? So now at that point we realized that our project is a little bit in jeopardy, but we realized that this man moved up the compassion axis, right? He is now suddenly, he feels for the constituency he is trying to serve. Now, so what he said, so now he said, what I want to do is, instead I want to say that leakage is going to be there. Are there problems that arise because of the leakage? Yeah, other than the shortage of water, are there other problems that arise because of leakage? And what he learned was that in many of the urban settings, most urban settings in our place, where the water supply is not 24/7, people put these pumps to draw more water for my home than my neighbor's home, and there are these pump wars, right? Now when the water supply is not 24/7 and water pressure drops, then and the pump is on, it sucks more water, creates vacuum, and when there is vacuum created in pumps, pipes that are leaky, outside impurities come into the pipe and begin to create bacterial contamination with which people get sick. And when people get sick, poor people have more of a burden of getting sick than a richer person who may even put a filter to filter it out, right? So he said, I want to really reduce the contamination of water, and so what I am going to do is I am going to make a pressure compensating valve here, which I will put in the incoming pipe, and when the pressure drops, so this is the pressure dropping on a daily basis. When the pressure drops, the valve will prevent water from coming in, so there will be no vacuum created in the pipe, and thereby everybody will be healthier. Okay, an example of moving along the compassion axis. So what are the? So one might say, okay, so what do I have to learn in terms of tools? Are there tools to sort of move up the compassion axis? These tools are really in social sciences. They really fall into two categories. One is the classical social science, which is where the purpose is really to do research to establish cause and effect relationship. That's one class of activities. But for what we need is more in the applied sense, where the with purpose is to understand the needs and insights, right? And those needs and insights are going to be input to the design process. The culmination of all of this on the applied side is really to develop a point of view that you believe in and that you want to cater to. That's where you are headed. And the way it's going to happen is through ideation, exploration in terms of interviews and surveys and so on, and experimentation. Now, when you do that, then what we tend to say is that along every axis you need to err. ERR, which is you need to experience, you need to learn the research tools, and you need to then realize. So in the compassion axis, the experience in our case, in the Tata Center case, is 6 to 8 weeks of working with the communities to understand their problems, like every year, and then if you get more excited, working more with the communities, but at least this much. Learning tools from human-centered design, anthropology, social science research tools, even basic tools are a great start, right? So to accelerate this process. And realization occurs when somebody makes a socially conscious choice in their design, like I was giving an example of. Or somebody makes a choice that chooses sustainability over profitability. That's another manifestation of it. And that's when you realize, okay, I moved up this axis, right? Okay. Any questions so far? Now I'm going to ask you a question. Before that, any thoughts? So here are questions for you. So for your project, there are 4 projects here. Can we take 5 minutes to answer 3 questions? where do you plan to experience or observe your problem, right? What is your method for empathizing? Just one word is even okay, I'm doing surveys or whatever it is, right? And what will be your measure of an empathetic solution? We take 5 minutes and then we will move on to the next component. Okay, at the end we are going to synthesize all of this and do some reporting. Are we all sitting in teams right now, or shall we sit in teams? It may be good to just move around and sit in teams. All right, keep going. Okay, so you have part 1 of your story. Okay. So let's go to the let us go to the next component. Can you hear me? Okay, am I on now? Okay, okay, good. Okay.
Can you elaborate the point?
Yes. Okay. How will you, that's a tough question, and it's harder to answer earlier on because it may become it may reveal itself as you go on, you know, as to along which dimension are you making a trade-off between maximizing efficiency and versus maximizing quality of life or whatever it is, you know. But I just wanted to see if that is already clear. In some cases it may be already clear. We'll see at the very end how it plays out. Yeah. Okay. All right. So let's go to the next component. So I will do research before practice because we now have to find the solution, right? So how does one know? So for our students, we think of this journey as how does one know what is rigorous research and how do you do it? Now this is something that universities are very good at, and this is universities is what teaches them doing that either in laboratories or in classrooms or whatever. I'll give you a couple of examples of specifically focusing on research. So by the way, I am picking examples related to water just to keep a coherent theme of some sort, okay, in the example. So people know about drip irrigation, right? So drip irrigation, of course, we know that this can grow more crops for much less water. That's the idea. And one argument is that the adoption of drip irrigation has been hampered because of the energy costs. So in drips there is this thing called the emitter, which the way it works is that there is the way most of the emitters work is that there is a membrane, you pressurize that membrane, it opens up and lets a drip out. And so now to create the pressure, when you have your farm and you have this system laid out and there are the emitters along the way, you want to create pressure, enough pressure so that the water drips. Now creating the pressure means generating energy to create pressure. That energy may be generated through, say, diesel generator or electrical power or solar power or whatever. And that roughly is 50% of the operating cost, which is very high, and so it becomes a barrier to adoption of drip. So now, what these people have done, Pulkit and his advisor Amos Winter, what they did was they decided that they are going to mathematically model the drip emitter. So they will model the physics of the emitter mathematically, and once they have a model of it to show why it behaves the way it does under current pressure, and they know the geometry of it and the impact of that geometry on how it uses pressure to let water out, then they can play with those parameters to redesign the emitter so that for much less for much less pressure of the order of 1/10 the pressure, you can in some topologies you can irrigate the same amount of field, right? Now the core and the operating expense can come down from, say, energy cost in particular can come down to half, for instance. Now there are other variables that interact with this, you know, what is the gradient and all of that, but you get the point. Now the reason I am showing you this example is that there is this nice problem that one understood in the field that I need to reduce the energy budget for this. But in the lab, the core piece of the work is to model the emitter mathematically, right, and assess its performance. Well, first understand how it works, assess its performance, tweak the emitter design a little bit, assess its performance, and do that loop until you are satisfied with the new geometry of the emitter, right. You may do that once you have done it mathematically, you can iterate very quickly on a computer first. Then you can, once you are satisfied with it, you can actually build these emitters and test it in a lab setting also, and all of that you can do. But that's really the core of that research, piece of research, right. So now you've gone from the field back to the lab and you've derived that core, right. I want you to focus on that core. Your idea also has one such core. Yeah? Okay, let me give you another example. These two people, Michael Bono, who is a postdoctoral researcher, and Sidney Beasley, they set out to look at contamination in rural water setting. I mean, these are people who build, Michael is a person who builds, he's an analytical chemist and he can build sensors. So he was interested in can he build sensor for point of use in rural areas. So the first question was which contamination to go after, right, because there is the biological contamination, there is physical contamination, there is chemical contamination, all of that. So after some field work, they zeroed in on biological contamination because that is really the most pervasive, right. That's you find it in every village of India. So they zeroed in on it, and then they took and so their original idea was that I will create a sensor which will tell somebody that there is contamination in your water. Then in the field they quickly realized that you can't really tell somebody that your water is bad without telling them what to do about it or where else to go for water, or how to prevent it from going bad and all of that. So they said so Sydney said that she will make some kind of a decision system. And then she realized that actually just telling somebody to boil water is, we're already telling them to boil water. The point is, why is there contamination in the first place, and why doesn't somebody boil water all the time anyway, right? So she realized that actually what really happens is that if you, so this 5-layer pyramid that you see here, she derived it from her field work. But she realized that places where community institutions are well functioning, they have the wherewithal to build and operate infrastructure for harvesting water. Other places, infrastructure itself doesn't come about because the community is not functioning. Now, if you have infrastructure, then you can harvest water and you may have sufficient water, assuming there is water in your environment. If you are in a drought prone region, then there is another problem. But let's say there is water in your environment, then it's harvested for people's use. If you have sufficient water use, then there is the question of adequate water for sanitation. Otherwise, there will be sanitation infrastructure, but there will be no water to have sanitation, right? So enough water will lead to better sanitation. Of course, assuming people behave the way they ought to behave in use of sanitation, all that. And once you have sanitation infrastructure working is when the water safety or bacterial contamination safety becomes possible, right? So she realized that there is this pyramid, and she really can't explain this pyramid to somebody just like that, and so she will have to build something which hides the complexity of the various components of this water system behind, but let somebody interact with this simulation to say, if I behave in this way, what will happen to my health? If I behave in that way, what will happen to my health? Type of a thing. So she decided that she will build the planning tool like that. Okay, this all came about from the field. Now, the reason I am showing you this example is, I told you all of this. So they are creating this sensor and a planning tool. Now, the reason I am showing you this is that they started out with wanting to build something point of use, for villages. They focused then on microbial contamination through field work, and they decided to build these two things, the sensor and a planning tool. But then all along they used multiple methods. So they used conjoint analysis on the sensor side to understand exactly what people want. So people said, I want a reusable sensor, I want it all inclusive. In other words, I don't want to add chemicals here and chemicals there, and I don't want those parts. I want everything to work for me, right? These are rural women saying, or men and women. They said, I want an electronic sensor that will work in less than 2 hours, right? So what does that mean, work in less than 2 hours? So current bacterial contamination can be detected only in 24 to 48 hours. Why? Because you have to grow the colony of bacteria so as to be able to detect it. So either you now have to concentrate bacteria better, and you have to also be able to detect it more efficiently so that you can eliminate that incubation step or growing the colonies of bacteria. That's the pursuit Michael is going through in laboratory. So this is his core research, right, in the lab. On the other side, on the planning tool side, what she did was she first did sort of she needed to understand two components. One is how does the physics and economics of this 5-layer stack works. That is already in the literature, a lot of it. Second is how do people behave with respect to water, and that she derived from the group model building type of sessions, and she has now built a system dynamics model where behind the scene is all of the physics and economics and behavior, but the interface allows somebody to turn knobs to ignore all of that complexity but understand how their choices influence outcomes, right? So now some NGOs are saying we don't have it working fully yet, but some NGOs are saying that they will package this into a behavioral change campaign where you start testing your water on one side, you start playing the planning tool maybe with children, self-help groups of women, etc. And by the time you have understood the planning tool, you will know how much contamination is there in their water, and then there can be a conversation about what can they do differently in order to improve that and so on. So now the point of showing you this example is really to say that not only is there a core of research that one wants to know, but there is a combination of methodologies that you may use. So there is no need to shy away from it, right? I mean, sometimes this is, for one, when I started on my research journey, it took me a while to realize that I really have no constraint to limit to one method. I can use whatever method I want, as long as I can get to the truth. That's really the point, right? Okay. So here, on this axis also you need to err, right? So to experience, what we do is in our case, we send students to learn from literature and research. Somebody said what are the existing ideas? That's learning from literature. And research labs teach them what research means. Then methodology is dependent on problem, as to what method you will have to learn well and apply to your problem and so on. And then when have you realized, this is the question of how will you get feedback on your research related output or choices or whatever, right? In our case, what is most valued is, of course, people will publish their theses or they will publish in peer reviewed research, and that will give them feedback that did they do it right, should they change something, etc., right? Now, the questions for you, so can we take 5 minutes for your project and write down, to produce this solution, what are the most important risks where you will need research? Okay, that's first question. Second, what is or are your most likely research methods? It may be one word or 2 words. And third, how do you plan to receive feedback on what you do? Do we take 5 minutes and write that down? Yeah, good. Are we good? Okay. Okay. So shall we go to the last component? Yeah, practice. Okay. So the practice, as I said, the basic question is, how do I think like a seasoned practitioner? It may be an entrepreneur, policy maker, NGO. I was saying there may be others. Social worker, teacher, whatever. So I'll give you a couple of examples of how our ideas seem to be getting out. Okay. So here's one of an idea of a startup, which is by somebody named Catherine Taylor. She and another MIT student, they are building a highly efficient centrifugal pump for the Gangetic Plain, where the water tables are high enough that you don't need really a very big pump. You can do with a small pump and a small solar panel, but currently what's available in the market is only the bigger ones. So small farmers can't really afford them. And so she's building one which is at 30,000 rupees with the solar panel. So it has a 2-year, less than 2-year type of a payback period for a 1 acre, 2 acre type of a farmer, right? And basically what she's doing is she's really engineering the heck out of the efficiency of this pump. That's a simple sort of a proposition there. So she has turned this into a Pune-based startup. So they moved to Pune and they are trying to do a startup in the final phase of productization to get it out, and that's their channel to get out, right? Now, I'll give you another example of Mariana Nobilino. She has turned her idea into a decision support tool for policymakers. So basically, she was working on using the water sensors of India and identifying where water infrastructure is failing, and giving that as a decision support tool to state level policymakers. So she's been in getting it out. She's been working with the National Informatics Center, which is a government organization, and Tata Trust, which is an NGO type of organization. So basically, there are 3 types of channels that we're beginning to see. It is a for-profit channel, which is maybe a startup, or it may be licensing to a third party for royalty or whatever. There is the government as a channel, where there may be either a decision support help to government or actual policy change based on what one has found. Or there may be an NGO where ideas are closer to community, and some kind of a social entrepreneurship through NGOs, or a philanthropic model that's helping NGOs, so plugging into that. These are the types of channels we are seeing for ideas to get out, right? So, when we are talking to a whole bunch of different organizations, this is just one snapshot of it. Now, there are, a couple of thoughts on partnerships. On one hand, amplifying partners is a great way to go about things, because they are already doing this kind of work, and they are resource strapped, and your work is trying to help them, right? So in some ways, it is really difficult for any faculty, all of you, me, to really get down on the ground and do a startup for 5 years. Unless I say that I'm going to be an entrepreneur, then I'm not going to be a faculty, right? So working with such partners really helps in 2 ways. One is it helps upfront in sharpening the problem statement better, right? But at the other end, it helps getting your ideas out. Now, there are some lessons that, so this is first of all not an afterthought. Let me give you a little final story about David, who you saw earlier, and his pressure compensation valve. So we built this valve, and we said that we're going to go to policymakers and say, hey, here is this valve. You can put it in incoming lines of the water system, and then there will be less contamination. And then one realized that actually nobody is really willing to sign on that dotted line to make this a part of the system, because they are seen as tampering with the water system, right? If I'm a policymaker, if I'm a corporator, and I want to be re-elected, I don't want to be seen as somebody who is messing around with the water system. So we actually haven't had a single corporator so far willing to sign this on the dotted line, right? So it's a major failure in some ways of you know, not thinking about implementation upfront. So that's one thing. The other thought is, how do you select a partner who is the right partner? Who is the right partner, right? So some lessons here are that you want to look for skin in the game. So do they actually do this regardless of you? That's one thing. Will they put some money? That's a great way of assessing skin in the game, right? Will they pay a bit for all of your effort? And if there are many such entities. So I don't mean to say there are a dearth of good partners. You can have great partners. So when you find them, partner with them before, during, and after. And you may find that you may need multiple such partners, right? There are people who are good for proof of concept type of work, but when it comes to scale up, you need a different type of a partner. Anyway, partnership is our way of doing it. Now, so one says, okay, so along the practice axis, how do I learn stuff, right? Coming back to the research tool, what tools do I have to learn? So in our case, we have been teaching some entrepreneurship work, which is very popular, either the 24 steps of disciplined entrepreneurship or the business model generation. And we've been teaching policy analysis and communication tools. So if one learns these tools, then one has the wherewithal to not only analyze, but go out and talk to somebody about this, right, when your solution is ready. So again, you're going to err along this axis also. So in our case, the experience comes from partners and prior art. Prior art is the idea of, you know, what exists and can I learn from it? And can I go to partners and get scolded a bit for not thinking this right and all of that, right? The tools, the research tools are going to come from empirical cases, so stories of various successes and failures. That's a great way to learn. Entrepreneurship tools, policy analysis tools, and so on. We teach people that. So to push them along this axis. And the realization comes when somebody either licenses or startups or does a startup or a decision to support tool or influences policy or begins to consult, help NGOs in making their decisions. All of these are realizations of getting, putting things in practice, right? Okay. So again, let's do another final 5-minute thing on practice. Okay, I'm going to ask you 3 questions. These are even harder questions than the ones we asked so far. First is, what would be your most likely implementation channel? Is it going to be a for-profit type of an idea? Is it not for-profit? Is it going to be government, etc.? Second, who will pay for your solution? If you had a solution, who is most likely to pay for it? And third, how many customers or end users would you want to reach out to be able to say that I feel this is a success? Okay. We take a quick 5-minute exercise here. Okay, I just wanted to summarize that. So I was showing you movement in this 3-dimensional sphere, right? Along each axis, you are experiencing something, you're learning tools, and then you are determining that what does it mean to have arrived on this axis, right? I won't. I'll let you take your photo, and then we will. So what we want to do is, we now want to do a team summary of maybe if you can all speak for a couple of minutes with each other and say, okay, what are the highlights that you want to, what are the things that you want to highlight about where, pick a person in each team who will talk about what is the problem you're working on, or problem, what is the problem and what is your likely solution, and where you have the greatest struggle in answering questions that I asked you. Okay, can we do that? And then we will do a little report from each team and some questions and feedback. Okay, so take a couple of minutes and synthesize, try to synthesize, right? Problem, solution, and greatest challenges. You are, okay, so here's the rule, here are the rules of the presentation, okay? So they're going to talk about their project, and then other teams are the reviewers. So you please tell them how to overcome their challenges, or what else should they think about, or whatever. Yeah, go ahead.
We have basically thought of two projects. Firstly, I would discuss the project one. The project first is regarding a portable device for biometric attendance. Like portable device in the sense that currently the biometric devices for attendance are available outside the gate of the classroom. So we want to bring it down to the register level. Register level in the sense the instructor comes with a register and calls a roll off and marks the attendance. But instead of that, he would bring a portable biometric device and he will circulate that device to the students, and they will put their fingerprint, and after the end of the class he will just get it and bring it to the central server and just sync, and the register, the attendance will get uploaded. So this is the target of our first project. And the problem that we are facing, that the most requirement is to make a low cost, portable and effective. And in fact it would be handled by many, so it has to be rugged also, robust, like it is unbreakable kind of thing.
Yeah.
So
that is all along this axis, right? It's all along the portable, rugged.
Yeah.
All of that.
A feasibility checking of this complete research is major part.
Yeah, that's what you have to crack.
Yeah.
Okay. Yeah. And what about, did you have challenge answering the other questions that were put up? How do you know that this is the problem?
Because we are academicians, we ourselves feels that universities impose us to purchase the device, but there are various the individual devices are so much expensive that if you place a device in 20-40 lecture halls and labs, the individual monitoring is not feasible cost wise. And if you are able to make a device in 1500 or 2000 rupees, then you solve almost the problem of all the academic institutions regarding the attendance and other attendance analysis also.
I see. Okay, thoughts, people? Any feedback, questions along the 3 dimensions?
Actually, we have already discussed our projects amongst ourselves yesterday.
Okay.
So that is why maybe they are not.
They don't have questions.
Yeah.
Okay. Okay. So maybe I can ask questions.
Yeah.
What about, you were going to say about the second project also?
Yeah.
Yeah. Go ahead.
Okay. The second project is regarding the overhead water tanks, like overflow. As soon as the overflow, we can develop a sensor which can like cut off the motor.
Yeah.
So that motor stops pumping the process, and as soon as we can have another part of sensor, as soon as the water level drops up to a particular level, then it again start the pumping process. So a threshold of the higher and the lower level is to be maintained with the help of a automated system, and some alerts can be generated with that.
So in the first problem, who will buy it? Like,
initially we can start with academic institution if you consider it to be private institutions, but since the government is adopting policy of placing the biometrics for the student attendance, so the government is also would be willing to spend in your project if you can give a very low cost device.
I see. And so what is the comparative cost of what you
Each device that is required is around 25,000 that we are purchasing,
I see.
and it is a basic device with not more than capacity of 500 users, unique users to be enrolled.
Yeah.
And the available device, this portable device, is around 5,000 rupees, 3 to 5,000 rupees. But that has various extra things which are not needed in Indian systems, and also they are optional. And we require that the matching should not happen. We don't require to match at a time of attendance.
Yeah.
The attendance can be matched at a central server. So the processing can be saved by centralizing the matching part.
Yeah. Okay.
So that is the main contribution that can reduce the cost.
Okay. And then what about the second one? Who is going to buy it?
That is directly for government only, because ultimately it is a water resource. And if you consider from the home perspective, household perspective, it will also save the energy. So anyhow, a person can also buy if you, but that requires social reform kind of thing, that person think of saving the energy and water for this. But still, government can directly subsidize the thing, that like they were selling the LEDs and other things at a subsidized price. So these kind of devices are also can be subsidized by government and can be purchased.
Urban.
It is for overhead things,
Yeah.
especially.
Yeah.
And majority of the times people don't even know that the water is spilling, and the neighbor is looking at the water, but they are not going to do anything. They will only say that your water every time it spills off.
Yeah.
But no one can actually do that, because we also face that our neighbors do the same things. But like, what can we do? We cannot cut their line or something.
Yeah. Yeah. And so
Huh. Human pump operator. Yes. Yes. Work. House.
yeah. And do you have? Yeah. Yeah. So these are sort of some aggregated. These are businesses you are now selling, as opposed to individuals.
These are like social connected business, actually. What we will term it more precisely, because anyhow there is a social cost, because being a government college, but in a government college, we don't think of funding problems and other things. But anyhow, it is a taxpayer money, so it has to be spent wisely.
Right, right. Okay. So the one thought is that, a lot of these has assumptions baked into it about what would the user want, right? I mean, one could counter argue and say, hey, actually, people may think that this actually reduces their water supply, amount of water that their tank gets, and therefore they will resist or whatever. I mean, you will have to go out and ask people whether this is indeed a pain point for somebody like that. So, any other thoughts for these people? Okay, so we move on to the next team.
Thank you.
Yeah. Thank you. Yeah. Please. Yeah.
The risk for this is like, let's say there is electricity failure and your shut off device does not work. People will trip for not having water for a day. Your sensor not work and the tank is only
Empty. Yeah, that your system is not working. They may kill him.
So one of the risks is like they were so power.
Yeah.
The motor could not be
Put on.
Yeah.
So robustness need to be looked up.
Yeah. That's one of your all of the failure modes you will have to test. Yeah. I see. Right. To use when there's no electricity, you can work on. Yeah. Of course.
Anyhow, the pump electricity is required. Like your sensor will work. Solar, the sensor can work,
But
but
the
not necessary the pump.
Good.
Hello. So basically our idea is to save the energy. So we are using the renewable energy resources, and in that the solar power is mainly we are using in our project. So our project is to grab the power of sun in every moment of scenario.
Okay.
Because if we settle down our solar PV panel in a particular manner,
Yeah.
so the sun changes, our earth is changing our
Yeah.
location.
Yeah.
So we want to grab every bit of sun energy.
Right.
So we are tracking the sun's energy by the putting the some automatic solar tracker.
Okay.
So this is our project. Basically, we want something bigger than, but is not possible in 3 days.
Yeah.
So we decided in solar tracker system.
Okay. And who wants it?
So basically,
Yeah. So one of the applications is sorry. First, please. Yeah. So one of the applications is you mean the solar farms,
Yes, yes.
that like the Tata Power,
Yeah, yeah.
etc.
Yeah, yeah.
Solar farms is one possible application where
Yes, yes.
yeah. Okay. Anybody else who might want it, or so that's is
The
that
problem is one problem.
yeah.
What happens is your initial cost on PV systems is very high.
Yes, yes, yes. This is the problem.
Also sort of, so there are some commercial solutions, for example, MPPT, maximum power point tracker.
Yes, yes.
So that you want to make best out of the capital that you have invested.
Yes.
And as the seasons move, as
Yes,
the
yes.
time moves,
Yes, yes. Yes.
so the solar is going to be. So if you want to sort of optimally use that what you have invested in,
Yeah.
Yes.
you would like to have. So it's a good project.
Yes, but the problem is only the cost. Cost is the major problem, because although it is very high cost, solar power is initial cost is very high, and we are just putting this automatic solar tracker from east to west again, and it definitely changed this azimuthal angle, these all kind of things from season to season. So it's a cost is a very big problem for this project.
So in this case, though, they will have to agree to redesign their product a bit so that it reorients the setup. Yes or no? I mean,
I think
so think of a use. Can we think of a use case for, let's say, in the case of Tata Power?
yes, yes.
Can
They
we
can use,
describe
but
the use case? Yeah.
they can use, but yes, cost will definitely increase.
So
If
they will
somehow
have
we
to
can
say
decrease
that
this cost.
I'll have to reorient my solar panel based on input from your tracker. Is that how it will work?
Based on this sun movement.
Yeah, so based on the sun movement, your tracker will say the panel should be
Yes, yes, yes.
oriented
yes,
this way
yes,
or
yes,
that
yes,
way or
yes,
whatever.
Yes, yes, yes.
And their panel
Yes.
would have to be capable of that reorientation,
Yes.
right?
Yes,
Not a
yes,
fixed
yes.
panel. They would have to mount it on
Yes,
something
yes, yes,
which
yes.
allows
Yes,
them
yes,
to
yes,
reorient.
Yes.
Yeah, yeah.
Yes.
And now, so, and what will your tracker do better than the current trackers?
I think the current tracker is single. Yes, please.
Actually, the tracker will rotate in 180-degree direction
Okay.
in the direction of the sun.
Yeah.
So the main problem is which I observe is first, if we are implemented at the ground level, the huge area is required.
Yeah.
And as far as energy is concerned, the return of this system is not too high at present as well. The maintenance cost is too high, and government is subsidizing up to 60% only. And the technical persons, especially in the be implemented at rural areas, is not more skilled. So high technical persons are required.
Yeah.
So these are the complications which
Yeah.
I feel to.
Right. And it feels like at some point you would have to begin to, if one were to take a project like this forward, one would have to already co-design with that intended user so that you can meet their requirements and they can give you what you want. Because I can imagine this becoming a part of a lot of different projects, right? But in each case, there will be some degree of customization that will be needed. Does one know what is the size of this market, and do we want to? Yeah.
If I start it as a business, right? So I need a huge area first. I have to pay some amount to the whatever the person to whom I hire it.
Yeah.
And as far as I take a loan, return is too high. From government it's 12% up to, and the return from this is not too much because government is just purchasing from 4 rupees per unit, 4 or 5 rupees, and selling it into market in 7 rupees, I think.
Yeah. So the
it's less from the existing whatever the conventional energy. It's high rather than this one.
So you may be better off
Therefore,
just licensing and getting a little royalty from this technology that they can integrate. Is that?
Put our system in the existing ones.
Yeah.
Which are placed in the system.
But
we can put our technology to that system.
Incorporate it in. Yeah.
But it's actually utilizing the existing resources. It's tracking the sun. Therefore, it will be beneficial to the existing one as well.
So you are eliminating this whole fixed cost that somebody has already incurred, and you are plugging into that.
Yeah.
Great.
Incremental.
All right.
Some of in USA, I've just read this. They are using already this like solar power.
Yeah.
In solar power, there was small, very long, there is a heliostat.
Yeah.
In this heliostat, the sun rays come, and they are tracking this. This heliostat is tracking the sun.
Yeah.
So they focused on this point.
Yeah.
And the temperature is 1300 degrees Celsius, 1400 degrees Celsius.
Yeah.
They can convert this solar power, all this cycle and all kind of things.
So
So they are using this technology, but this solar tower, we can say.
So the idea of tracking is very attractive.
Yes.
It's a very interesting technological challenge.
Yes.
It seems to me that I think the challenge here is that can you be a component supplier to this industry, or must you also build then the solar panel? That's really the, or you build this thing and then somebody like Tata Power will say, okay, we'll buy you, come into our setup and let's create this integrated product. Or so great, all right, super, thank you. Yeah. So
for any small system, like for Tata Power it's fine, but let's say a school or a hospital or something like that. What in conventional management you do is something what we call as a SWOT analysis. Right? So, for example, how about if I hire a person every 2 hours, he does and changes. I mean, you will do some kind of a alternative building scenario that I have a completely automatic solution and partially manual solution. Because every 2 hours is fine, 8 to 10, 10 to 12. The sun, itna matlab ye nahi ki minute by minute you have to track or something.
yeah.
So you can sort of build scenarios. How if I have a sort of man employed to change the for a smaller system? Like
no, right. You could do that. Yeah, that's a nice use case because then you are making it manual. Maybe it's mechanically mounted so that it can be rotated, etc. Yeah, right.
That you can change the sort of thing.
Yeah.
And then next morning he comes and puts it towards his field.
Yeah.
Kind
So-
of a alternative.
Yeah. But I think it is interesting to note that I think whereas your challenge was a lot to do with on the technological axis, your challenge, of course, technological challenge is accepted, but I think your challenge is going to be after you make the technology in some ways, or you have to integrate beforehand to say, okay, where am I going to put this? Okay, let's move on because I realize that we are already a bit out of time. So we have two more themes. Sorry, you were going to say something? Yeah, sure. I see. Yeah, yeah. No, that's great. So you will explore a different concept here. Yeah, yeah. Right. Okay. So you say here are two concepts we have tried. Let's try another concept. Okay, okay, okay. That's interesting. Yeah, yeah, yeah. That's great. In Vigyan Ashram. Oh yes, I have. Okay, I've spent time in Vigyan Ashram. So right.
So our project is to reduce the power consumption in a organization, government organization or a township. So there can be two applications for this, like we are specifically demanding it for like reduce the power consumption during non-working hours. For example, there is a government college or any organization where people have a tendency to leave the lights and ACs open after work hours. And we do not get to know it, and next day when the person comes, then only the light that is switched off. So so unnecessary, there is a huge power consumption and leads to great electricity bills. So we want to devise an automated system which can cut off the power, or at least it will notify at a central gateway so that some person can go and switch off the ACs or light. So that is our major problem statement. And the possible solutions of this is, first we have smart energy meters at, for example, if I'm devising it for a college, so I need to have smart energy meters at like outside each classroom, and then I need to take data from all those energy meters to a common platform, for example a smartphone, and then it will notify, and then I'll get to know, and then I'll take the control measures. Second possible solution is to have, like for light, I can have smart diodes, and for ACs, I can have temperature sensors, which will notify, but they need to be smart so that they will pass on the information to a common gateway. And one possible solution was telling it was related to some microcontroller and IC.
The same thing that we can implement smart energy meter ICs, okay, where we want to measure the power consumption, and that can be interfaced to microcontroller, and that can be interfaced to a display system where we will monitor the power consumption of a particular place during off hours. If the power consumption is high at that time, then we will know that there is a problem or some appliances are working on. We can go and make it off. So this is the solutions. And what else?
So
Challenges.
Sir, major challenges are cost effectiveness. It should be cheaper so it can be implemented, and also it is right now we are thinking at a small scale, but it should be scaled up. So it can be implemented in township as well.
yeah, yeah. Okay, so I understand that you are still picking between the three different concepts that you may explore. That's an interesting challenge also. But so one question I had was, who feels the pain of this excess use of electricity? Who feels it?
Just observe that in our institute last month electricity bill was around 4 lakhs. So I thought it was too high.
Yeah.
And government body is paying. Government body means taxpayers' money.
Yeah.
So we should reduce it. And I saw many times that after class time, no one was there in classroom. Still fans and lights were on.
Yeah.
So it should be switched off. But it is for, I think for 1 month it was. Yes.
But who feels the pinch of it? Like for instance, when I go to farmers in Gujarat, they get free electricity. They are using it. nobody's feeling the pinch. Like I say, well, this is taxpayers' money.
Actually,
Yeah.
our college is at a rural place,
Yeah.
we live in semi-urban city, but college is at the rural place. We have frequent power cuts, okay, due to scarcity of power. Okay, so we ultimately feel the pain at that point.
Yeah. So you're assuming that if you use less power, then others will have more power?
Maybe this is a step we need, but as a human being, we should go for this.
No, I understand that this is but this is a global climate change type of a problem, right?
No,
I
no,
mean,
no,
it's
no,
like, in this, no, what I'm saying is that nobody, so this 4 lakh rupees is nice argument. The question is, does your college, is somebody in your college, let's say the accountant or the principal of the college or whoever, do they actually talk about this? Is this a problem?
See, from where this problem came is, this year in the month of May, where the vacation time is going on, or let's say March, up to March, January to March, we got the bill of around 6 lakhs. But last year in the same period, when we compared the bill, it was 3 lakhs, okay, nearly half.
Yeah.
So something has happened this year, so that we got nearly double the bill.
Yeah.
So this was the matter of discussion in the principal office one day.
Yeah.
I was sitting over there. So I thought of like that.
That's nice. Okay, so there is a manifestation of the problem. That's really important. By the way, I thank you for first articulating the problem and then your solution, because I think a lot of times what happens is that we articulate the solution as opposed to what the problem is, that I am building X, I am building Y, and the thinking is that, the assumption is that people know about the problem, but actually I think definition of the problem as to, okay, so reduction of the electricity bill by how much, and so on is another sort of, one can go on about defining the problem more and more. And I think, how does it manifest? Who will make the decision about if you came up with something to invest so that their electricity bill comes down? I think that finding that in such a case, finding that person who actually cares is something that we tend to spend a lot of time on, because we kind of realize that, oh, funny, if I build this, who will care for it? So, yeah.
In this domain of energy conservation,
Yeah.
we always take a simulation to game of cricket.
Yeah.
What we say is run save
Yeah.
is more important than run made.
Yeah.
So you tell a utility
Nice.
company that if you conserve that many kilowatt hours, it's much better than generating that much. So
Yeah. So you'll have to, I think rest of this program will hopefully take you in the direction of making that argument quantitatively, as to, that if I, with my system, you will save so much, and that has a payback period of so much.
This problem is, like, if people know that there is such device in the market, then the general quotient of switching off the lights and switching off ACs might go. Like, if they know if there is some such thing in the market, then they will forget this, they leave this habit of switching off lights and AC. So this is a great challenge.
This is another, you change the behavior for the, it's
a behavior change. And one possible challenge, like, if our device is not cost effective, then people may say, like, no one would buy. Instead, they will suggest that at the end of working hours, somebody will go and switch off the lights, which is a common practice.
Yeah.
So
if your device is ready, here is a buyer, we want 15 of them, please inform Gayatri that our device is there. I want to put on our seats for you.
Yeah. Oh, perfect. Yeah.
Please inform her when your product is ready.
All right, great. Okay, so let's give them a hand and go to the last team. And I am way over time. Okay, you have your. Okay.
So our project is designing a portable, foldable rainwater shelter in agriculture.
Okay.
So the
Nice. Okay.
so problem arises due to we have experience in farming. So what we can see there is that like potato farmers mostly, or maybe some other farmers, so they require the rainfall in some season, and in some season they don't require any water. So the irregular rainfall in that areas, creating problems for higher production of the potatoes. So normally in October to November, this season is the cultivation season, and after the cultivation, for like 1 month, there is no need of rainwater. But there is a heavy chance of rainwater at that time, and after that, the farmers spray lots of pesticides. Because after that season, like high humid, and then rainfall season, and that time the potato blight disease is spreading throughout the field. So once the potato blight starts, then within 3 days or 2-3 days, the whole field will be devastated. So due to that, they are applying this pesticide for before the potato blight. So once they growing the potato plants are growing, then they starts to spraying the pesticide whenever it is not required also. So they sprays it for a number of times, around 4 or 5 times. So this is a huge cost.
Yeah.
So expecting the chance of the blight, but so we want to design a rainwater shelter which will be utilized in agriculture, that will protect it from rainwater, and we will harvest the model will we will try to harvest the water from that and reuse the water whenever it is required. So the challenges is like designing of the shelter can be of because it should be foldable, so that it will could be robust and ease of use for the cultivators. And the material which will be utilized, we are planning to use recyclable plastic wastes, and the cost.
The cost, okay.
Yeah.
Yeah.
So the.
Okay. Any thoughts for people?
So in one line, if you were to ask her what is the problem definition, what are you looking for as a solution? You understood the potato blight problem. Is it forecasting of what exactly the problem?
Rainwater shelter.
Shelter for the potato field. Yeah. So.
If you look at the like you have what we call typically as protected agriculture.
Yeah.
That's normally for small plots, like.
Yes. That is the challenge.
Acres of potatoes.
Yes. That is the big challenge. But we are trying to make some foldable kind of design, so that we can press and make it smaller whenever it's not required.
Okay.
And
so there will be multiple of these?
Multiple of the units.
So each little plot will have a shelter, and then another plot will have another shelter, and like that.
Yes.
Okay. That's, yeah. I think with agriculture, and Professor Shah may have thoughts on this, but what I feel is that the greatest challenge, so let's say you design the shelter, it works beautifully. The greatest challenge is to then tell the shelter story in the form of how much money in farmer's pocket. In this case, it's easier, I see, because this idea of pest and everything getting wiped out at a point where you have already incurred all the expenditure and your risk is the highest and the consequences are also highest, is easier to tell that story, right? That it is one-time investment. It will be reused. So and then there is a question of if I make multiple of these, and if I am a 1 acre farmer, how will I? This is the argument you are making is an insurance company argument, right? That you have so much chance of getting blight, and if that happened, your return is going to be 0. So why don't you spend X amount of money, and and you will protect yourself from that chance. But if there's no blight or there's no rain, then you're going to feel that I paid this premium. And
but if there is no blight also, farmers are, because they are in always fear. That
they're always in fear. So you are sort of monetizing that fear in some ways.
So they are spraying the pesticide through around 2-3 months. Require.
They will confidently, they don't depend upon the forecasting.
Yeah. Right. And then it adds some other components like the labor cost and all of that. That I have to spread this, I have to get it out. All of these things begin to become interesting.
So some few days back I went there, then the pesticide use is so high that they are using pesticide along with some adhesive, they said.
Yeah.
They buy some adhesive so that it should not run away.
Yeah. Right. We have a nice project on that.
So what, I mean, if I were to study this problem, immediately what I would see is like whether the blight is airborne or waterborne. Like they are saying that rainwater brings that. So then whether the sort of target awareness, is it bacterial or is it coming through some virus or is it fungus? So trying to understand the blight, the biology of blight. Okay, that I would understand. Then second, for example, I was involved in a project with one of our professor in Professor U.B. Desai in electrical engineering department. We did that for grapes. You might know an area in Maharashtra called Nasik. There's a lot of grape farms. So they were exactly doing something like this for grape farms. What we did was we devised what you call, or it was available, it's called leaf wetness sensor. So what we do is like on the grape plants, we put this electronic leaf and we developed an index called leaf wetness index. And we forecasted or predicted what is the probability that you would have such a kind of disease, leaf disease, and then give an advisory to farmers to spray or not to spray. So that saves them a hell of a lot. We talked to a guy called Rajiv Samant, who runs this Sula winery in Nasik, and he did test our thing. And then you can, like, once it is an electronic leaf and then all these communication devices. We had for example, Nasik is about 250 kilometers from here. So we had our server here and we were talking to those sensors in Nasik farms. So perhaps it can do, but again, all this cost economics, whether, if it is an airborne, then you cannot use shed net houses. You know what is shed net house? Plastic with the holes. That's called shed net. Green, white, वगैरह दिखते हैं ना. So that is called shed net. Then there is typically something what the people use in Europe and where Chintan comes from in US. In the temperate climate, they use complete glass house. So glass house means it will not allow, exchange of air also. Yeah. Whereas the greenhouse, because of its perforated thing, the sheds that they use, therefore it's called shed net. It allows the sort of movement of air. So as soon as you would have air coming from, and if your disease is airborne, you can't stop it, right? Howsoever you would cover it. So plastic, if you are covering, are you covering only from top? Then the blight may come, the vector of this disease may come from sides also. So I'm just suggesting all these practical issues, but it is an interesting problem. Yeah. Please invite me to Northeast, or
Sure, sir.
we would like to sort of, explore working on such a problem and what could be an optimal solution to this. Yeah.
Sure, sir. I will be happy to invite you to our place. Whenever you are free, sir, let me know. I will may email you, sir.
So invitation forced, huh?
So in closing, let me just say that, one of the things that I think collectively we probably realize is that we're probably spending, all of us spend a lot of time on this, right? And we do want to start thinking about this because I think they interact in interesting ways and they have implications for your design decisions. So think about that end user. Who will pay? How will you convince them? And therefore, what should you make? Okay, let's just close there.
Very nice.